Recently we have introduced concept saliency maps, which are a novel method to visualize relevant features in generative models such as variational autoencoder. And they can be understood as a generalization of saliency maps, which have been used for quite some time now in the context of supervised models, and which aim to make these model decisions more interpretable. The basic problem is that, especially in deep learning, it is not immediately clear which input features most strongly influence a decision made by the model. And this is usually done by calculating the gradient of the class score with respect to the input features, where the class score is the activation of the neuron in the prediction vector that encodes the class of interest. So how can we generalize these saliency maps to unsupervised models if there is no class score in these unsupervised models because we don't train them using any labels? And our approach was to use so-called concept vectors. And concept vectors encode high-level information or high-level features about our data set in the latent space, and they can, for example, be used to manipulate images by adding or subtracting them from certain latent representations of your images. For example, we can add a smile to a non-smiling face. And our idea was then to calculate a similarity score between the latent vector and the concept vector. And in this way, we have a drop-in for the original class score now in an unsupervised setting. For example, the similarity score is able to differentiate between images that do contain such a blue square and images that don't contain it. And concepts can be defined, for example, by any labels that might be available, or by a clustering, or simply by the user by choosing representative samples for a certain concept. And now here are some results from the CelebA dataset, and we see that, for example, the head, the eyeglasses, and the eyebrows get nicely highlighted depending on which concept vector we are choosing. There are much more details about this method on arXiv and also in the proceedings of the last year's ICMLA conference.